Welcome chemistry to a new day and a new chapter, chapter 12. Most of you will be quite thrilled to know this is a math-like chapter. There is no math today, no board work today. There is a minimal amount of math work tomorrow, but someday, like test kind of stuff on this, there's only 9 problems on the test. So it's extremely math light in that sense, day by day. A lot of days, none. Today being one of them. So what should have happened by now is that you read 12.1, you took some notes maybe, you studied a little bit, you tried to take a quiz to self-test yourself and absorb some ideas. If you haven't done that stuff, go ahead and do that, circle back to me. What I'm working from is the 12.1 quiz, just giving you answers and trying to explain what these ideas mean. So here goes some answers. 1 is about solids and liquids, chapter 12. The first 6 sections are about liquids, and then in section 7 they'll transition to solids. When you read 12.7, it's almost an identical read to 12.1, which was almost an identical read to a section about gases once upon a time. They're just going to give you the differences in the same categories among all 3 of those different kinds of items. 3 today, yes, everything is still in motion to some degree. Gases were in constant rapid motion, you might remember. Liquids, yes, still in motion. Solids, we're not going to commit yet. We'll talk about that when we get up to 12.7. For liquids, number 4, there were 3 ways in the reading they said that the molecules are acting differently than in the gas chapter. So 1 is that they're closer. 1 is that there's some attractive forces for the molecules, unlike last chapter when there were none. And then the collisions are not perfectly elastic, as opposed to last chapter gases, they were perfectly elastic. Reminder of what that means: perfectly elastic means you're not losing any energy. So when the gas particles bonk into the other gas particles, they're not slowing down. They're not speeding up. They're just doing the exact same thing they were doing with their amount of energy they had. For liquids, and we're not committing to solids yet, there's some energy lost. Every time they collide into each other, some energy gets lost in that game. 5 to 7, you were looking to name 3 things out of the 6. So they were talking about expansion being limited. Gases were unlimited. If this were perfume and I opened it up, that smell would fill the whole room. This being a liquid, it is presently not filling the whole room, because if it were, you'd be witnessing me drowning on a video. And that would be, I'm sure, a great moment of sadness to all of you to see your chemistry career end with your teacher drowning by opening up a water bottle in his room. The second thing here is the shape. It's indefinite shape, liquids being similar to gases. Gases have no particular shape. Liquids have no particular shape. This just takes the shape of the container that I put it in. They're not committing to solids yet, but one day you'll read about solids and they'll be talking about shapes when you get up to 12.7. Volume, they maintain their volume. So gases don't do that. Gases, we talked about, would fill the whole space. They fit in any container, they filled all the space. Liquids fit still, they'll fit the container, but they aren't going to fill all the space. You can see my water bottle is not filled. There's some empty space. It's not like this water expands to fill that. That's not the way liquids act. Again, solids we'll talk about someday. But they'll maintain their volume. The amount of water I have here is the same, whether it's in the bottle or down my throat or spilled in a puddle. The volume remains the same no matter what for liquids. Compressible, gases were way super compressible. You can compress a lot of gas in a small space. Liquids, today answer is slightly compressible. They talked about brake fluid being an example of that. You press on the brake pedal, it's going to compress some liquid somewhere in your brake system. It makes your car stop. If liquids compressed like gases, you could not stop your car with the kind of brakes they operate on with brake fluid. Density is mentioned. Okay, it's high density in this chapter. They did an explanation to eventually get around to the kicker that H2O, water, is 1,600 times more dense as a liquid than it is when it's a gas, as steam. Steam, I wouldn't recommend putting your hand through steam because it can burn you, but you easily can move your hand through steam being a gas. You can't as easily move through water. Some of you might have done physical therapy things where you're running through water or exercising in water. Water is difficult. It gives you resistance to try to get through it. Steam does not, because water is much more dense than steam. H2O ice, someday we'll talk about that relative to density. And then the last topic was mixing. Okay, gases easily, we're just freely able to completely mix. Liquids, they're slower mixing. You can mix liquids together. I could put some other liquid in this and stir it up and make them mix. That's done, but gases mix easier than liquids do. So liquids, it was slower mixing. So that's what 12.1 is about. There's no math from 12.1. If you want to work ahead, the only thing that pertains to this ever on homework is 1A. Whatever 1A is, I mean, you could do that, but I don't see that as a great advantage to your life. When you go ahead and read up the next thing, the next thing is 12.2-4, which will have some mathy stuff. There's 9 fill-in-the-blank questions you'd be reading for and try to prep for and do. And while we're not grading these quizzes, what you want to do, I think, is a little bit flip your attitude switch away from grades, 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 to just learning. Just try to learn some stuff. See if you can learn and just enjoy the learning process and try to pick up some things and just get smarter about some liquids and some solids and gases and the things we're talking about. But it's not so much anymore about grades, grades, grades. It's just sort of right now, let's stay safe and healthy and let's try to learn some things. And that's just where we are. But 12.2-4, again, 9 fill-in-the-blank points from reading. Question 1 will stay the same, liquids and solids. Question 3 stays the same, yes, they are still in motion. Question 4 changes to name all 3. So they're closer, there's some attractive forces, and the collisions are not perfectly elastic. And 5-7 changes to name all 6 characteristics, which is limited expansion, indefinite shape, maintained volume, slightly compressible, high density, and slower mixing. So I hope that helps you out, and I'll see you next time.